Oh, welcome to Taxonomy Online Mathematics. In this video, we are going to treat the topic matrices or matrices. If you are new, consider subscribing to the channel. Click on that notification bell to receive notification anytime a new video is uploaded. Don't forget to like the video after you finish watching. Recommend to somebody if you find it educative, and leave a comment for us to get interactive. Now, you know, in everyday life, everybody likes to arrange things in order. We all want to put things in a certain order. Taking our classroom, for example, into consideration, students are arranged in rows and columns. If you come to our communities, a well-planned communities, house buildings placed in a certain arrangement. Then for the boys who have been following football games, know that teams are arranged in a certain order when they come to a league table, whereby the win, the loss, the draws, the points accumulated, the number of goals scored, all those things are placed in rows and in columns. So that arrangement explains the concept of what? Matrices. If you arrange objects or elements in a certain order, whereby there is a columns and rows, then we have what we call matrix. So we have all been arranging. Books are arranged in shelves, so many things. Even your fridge, you arrange things in certain order so that you just go straight forward and know where the items are. Provision stores do the same. So if you are saying matrix, matrices stand for plural, while matrix for a singular. It's just a rectangular array of what? Numbers, or simply put, element. Rectangular array of numbers or what? Element. Whereby these elements are always arranged in rows. Rows in this case mean horizontal arrangement. Then columns of a rectangular array. Column simply means vertical arrangement of the element. By what? Either a square bracket, which is this, or by a parenthesis. So what we mean is that we use capital letters to represent a matrix. So if I have a number, let's say 4, -1, 6, and 3, you can see there is a horizontal arrangement. I write 4, -1, I come down 6, 3. Horizontal. I have 2 horizontal lines. Then it also have 1 vertical, 2 vertical. If I place this in a square bracket, I am representing what they call a matrix. You get the point? This is the arrangement. If I also have, let's say, you can also see that there is a horizontal arrangement. There is a vertical arrangement. So this is also a rectangular. You can see even this look like a square, but all in the same family, a rectangular array. So this is just the concept of matrix, how matrices are represented. Now, the size of a matrix determines the order. What is the size of the matrix? Now, since we are saying that we are using rows and columns, if you want to describe a matrix, we describe the matrix based on the number of rows followed by the number of columns. So I'll ask myself, how many lines of horizontal line am I having? In this case, I have 2. Then, how many of the vertical lines am I having? I am having what? 2. So I'll call this 2 by 2 matrix. You get me? 2 by 2 matrix. In this case, we said m by n, whereby the value of m and n are the same in this case, meaning there are equal number of rows as the columns. Alright, if we come to this place, if I were to label this T, how many horizontal line are you seeing? I believe you can see 1. There's only 1 horizontal line, that is 1 times how many vertical lines? I believe you are saying 3. So this is going to be 1 by 3 matrix. So the size of the matrix of this is 2 by 2. What is the order of this matrix? 2 by 2. What is the dimension of this matrix? 2 by 2. So can you tell me the size of this? 1 by 3. Dimension 1 by 3. The order of this matrix 1 by 3. So if we have C, we have array. I'm sure you can be able to tell the order, the size, and the dimension of this matrix. I believe in your mind you are saying this is going to be definitely 3 lines by 2 vertical lines. So this is going to be 3 by 2 matrix. Now, since we know the size, we know the order, we can also try to tell what are the various types. What are the various types of a matrix? So types of matrices, we have what we call unit matrix, and finally we have diagonal matrix. Now, unit. If we talk of a unit matrix, whereby let me use I to represent this unit matrix. A unit matrix is a matrix that have the leading diagonal all being ones. That is 1, 1, 1, 1, 1. And all other entries being what? 0. Leading diagonal simply means that the movement this way, this is a leading diagonal, and this is the other diagonal. Leading, the other diagonal. So the leading diagonal being 1, and all other entries become what? 0. So you can call this a unit matrix. Every other entry is what? 0. Apart from the leading diagonal, that is going to give you what? Exactly 1, 1, 1, 1 entries. Alright. Then if you come to 0 matrix, that simply means that all the entries, all the elements, or all the numbers are going to be 0. So if I have a 0 matrix in this way, by the way, this is 2 by 2 matrix. So this is a unit 0 matrix by 2 by 2. This is 1 by 3, which is still 0 matrix. This is also a 0 matrix. So these are the example of 0 matrix. It doesn't matter the size or the order. As long as all the elements are 0, it is a 0 matrix. Then a square matrix. A matrix is square if the number of rows equals to number of columns, as is M by M matrix or N by N matrix. I mean 2 by 2 matrix, 3 by 3, then let's say P by P, as in 4 by 4 matrix. So if I have 1, 3, 1, 2, this is 2 by 2. It's a square matrix. If I have 1, negative 1, 3, if I have this matrix, this is also an example of what? A square matrix, because number of rows equal number of what? Columns. You get it? Good. Then this is more or less like a square matrix, whereby number of rows different from number of columns. If I have P by R matrix, as in 1 by 3, 2 by 1, then 3 by 2, those are rectangular. So typical example is this 1 by 3 matrix. If I have, this is 2 by 3, 2 by 3, so it's a rectangular. The rows are different from the columns. If the columns are 6 and the rows are 5 or 2 or 1, then you and I are having a rectangular matrix. This diagonal matrix is more or less like a unit matrix, whereby the leading diagonal consists of numbers which are not equal. Then all other diagonals or areas contain what? 0. Let's see. if you have this matrix, this is 0, 0, 0, 0, 0, 0, 0. Don't forget this 0 is in line with this. This is a diagonal, the leading diagonal. But since this and this are different, this is not a unit matrix. This is not 1. This is also a number in this case. It's not assuming that this and this are the same. So since I have it here, it's not going to be diagonal. No, it's a diagonal matrix because the leading diagonal consists of unequal numbers. 1, 3, 0. Then if I have this matrix, we can see this is also 1, 3. They are different. So we can also call this diagonal matrix, different from unit matrix. Good. I believe at this point you will grab the concept, the whole concept of what? Matrix. Now, as the word itself explains, equal matrix. Equal matrix is a matrix of the same size, the same order, 2 by 2, 2 by 2, 3 by 3, 3 by 3. And if each of the entries, corresponding entries are the same, as in if I have matrix A and B, if matrix A is equals to B, then it means that the element in each entry correspondingly should be the same. So the first element should be the same as this, meaning A is the same as what? 1. The second element, which is 3, should be the same as this, meaning P is 3. This is 2, it should be 2, 4, it should be 4. So if you are talking about equal matrix, the matrix should be of the same order, 2 by 2, 3 by 3, 1 by 1 if there is. Then we should be able to have the entries, the element, correspondingly, their position should be equal. You get the point? Just as we have for vectors, corresponding areas are going to be equal. So this is an example. Let's take a question in this effect. So we have to find the value of A and B if matrix E equals to matrix F, where matrix E is A minus 2, as in first entry, 6, 3, B plus 1. Then that of F is 6, 3, 6, minus 7. If they are equal, first you have to check whether they are having the same order, size, dimension. Then if they have the same dimension, that means each entry is going to be the same. So that means that if we have E equals to F, it means A minus 2, 6, 3B plus 1 should be equals to the matrix 6, 6, 3 minus 7. They are equal. So if I lift this, it should be the same as this. So that is going to be, it implies that A minus 2 should be the same as what? 6. If A minus 2 is the same as this, then we can add 2 to both sides to carry the 2 away. So I'll be having A equals to 6 plus 2, where A is what? 8. Good. 6 is the same as 6. 3 is the same as 3. So it means B plus 1 should also be the same as what? Minus 7. Right? Good. I need to subtract 1 from both sides to clear the 1. So B equals to minus 7 minus what? 1. So in this case, B is going to be minus 8. So A is 8 and B is what? Minus 8. So this is how we can find the equality of a matrix or matrices. I believe you get the concept. All right. So let's see how we can also talk about the addition and subtraction of what? Matrices. So if in case we have matrix A. Now, if you are adding matrix or subtracting a matrix, what it means is that the matrix must be of the same size, the same order, 2 by 2, 3 by 3, the same order. Good, that is 1. 2, we are adding a corresponding matrices or element, corresponding element. So if I want to find A plus B, meaning this is going to be matrix A, B, C, D plus that of E, F, G, H, that will give me an answer to be A plus E to be in the first entry. The second entry will be B plus F. The third will be C plus G. Then the last will be what? D plus H. If you are to add, you add corresponding element. If I am to find A minus B, it is still A, B, C, D minus E, F, G, H. So putting this together, corresponding subtraction. So that will be A minus E. Then we have B minus F. What of C? C minus G. Then finally we have what? D minus H. So if you have two matrices you are asked to add or subtract, just identify them to be of the same size. It must be of the same size. Then the corresponding element of the matrix will be added or subtracted. So if in case I have A to be, so in this case A plus B is going to be 1, 3, 4, 6 plus minus 1, 3. So what am I going to do? I'll be adding the leading element or the first entry plus the first entry. 1 plus minus 1 will give me what? 0. 4 plus, okay, let me indicate that. 1 plus minus 1, 4 plus 1, 3 plus 3, 6 plus what? 7. So in this case, you should be having 0, 5, 6, and 13. So if you are to just add any matrix addition, no matter what the elements are, you are only adding the corresponding entries. I believe you get the concept. Just the corresponding entries. Let's try one. So given that the vector matrix A is 1, minus 3, minus 4, 4, 7, minus 1, 0, 4, 12, 1, 3, minus 9. We have to find vector A, how do you call it, matrix A plus what? B, matrix. So it means that A plus B will be adding this matrix to this matrix, which will in turn become 1 plus 7 minus 3 plus minus 1 minus 4, 0, 4 plus 4. This will give you 8. This will give you minus 4, and 8. So vector A plus B is just going to be this value. I believe at this point, I will leave this for you watching to also try your hand. C, which is this, minus what? B. So try that and see what you can also arrive at. I believe at this point that you have a fair knowledge of the topic matrices. In the next episode, we'll be dealing with the properties of addition, the scalar multiplication of a matrix, multiplication itself, its properties, and finding either the inverse or finding the determinant of a matrix. Don't miss that. See you in that episode. If you are still here, consider to like the video if you find it educative. Comment and share with your learning mate. Bye-bye.